question for 20 minutes. Please, welcome Jeroen, please.
Right. So thank you everybody. I'm Jeroen Willemsen. I'll talk a bit about it later. My talk is about creating AppSec pipeline of containers in a week and how we failed and succeeded. Now, first of all, I would like to know about you guys is who of you has a CI/CD pipeline? Can you raise your hands? That's actually pretty good. How many of you have a security automation pipeline on top of that? All right, for you, I'm sorry, the talk might not be as the talk might not be that interesting then, because I wanted to create a lightweight talk to inspire people that don't have it yet. But don't feel bored too much. You can always ask me questions later on or interrupt me when necessary to show off that it can be done way better. All right, a little bit about me. I'm Jeroen Willemsen, come from the Netherlands. That's why the name. Right now, I fulfill the role of a security architect. I have a long background in full stack development on mobile, doing web apps, creating scalable backends in several languages and stuff like that. And I've always had a knack for mobile security, as in how do you secure some content on a mobile device? How do you make sure you can interact with it safely and stuff like that? So, what are we going to talk about? We're going to talk about the challenge, the solution, the bumps on the road that we found, and then we're going to do a short recap. One thing I have to say, we did this at the end of 2016, so that's where this talk is about. We had a week then, and you probably attended some of the talks today and yesterday about the new tooling, and it became absolutely far more brilliant. So the stuff that you're going to see might be a bit dated, and you could have done it much better if you used modern tooling or the modern versions of the tools that we talk about. Still, I hope this will inspire you to see that it's not that hard to do it anyway, given either the older tooling or the newer ones. All right? So, the challenge. We basically had to automate security was the request. And the customer asked us, how much time do you need? And we figured we might be able to do something in a week. Let's see how far we can come. So we started off with just me and my colleague to see what we could do there. Basically, we spent about 34 hours on the project, and this is the result we're going to talk about. So let's just first talk about what had to be automated. So there's a bunch of legacy systems there, which are for some warehouse management, some fleet management stuff that you can't just Dockerize. I mean, you know, your scanner with which you could scan a packet somewhere in a warehouse, that's not going to run in a Docker container somewhere else. But so there's some legacy systems there. On top of that, there's a bunch of Amazon Web Services. So there's a bunch of Docker containers running, providing functionality, modern APIs for an Angular application, an Android native application, and an iOS application. So that was the landscape we had to do something with. So how was that stuff being built? Let's focus a bit on the backends first. So, well, most of you know how this works, right? You start with Jira, developers together with the PO, create stories, etc., etc. Based on that, they start creating feature branches and stuff. That's the flow that Git flow that they normally use. They would annotate those with the stories so that everybody would know why the code was there in general. And then we start with beautiful containers. So we use a stateless Jenkins container where we use the job DSL to just parse everything and automate everything away. And what it would do every now and then, given a C job, take all the projects, then start doing pulls on every of the projects, start figuring out the merges and stuff like that. And based on that, it would start the pipeline by building. And that building was, of course, including quality tooling, all that jazz, which you've seen in other talks as well. So let's not concentrate on that one right now. Then it would store an artifact. So it could be a WAR file, a jar file, or some other program, or an Angular set of files for an Angular application, stuff like that, or a Docker container where everything will be in residing. And then it would deploy the containers containing these artifacts to dev. In the meantime, based on that artifacts, a bunch of unit tests will be run. And of course, based on the deployment, they would do a set of end-to-end tests to see whether this worked or not. And then when everything was very green and stuff, you would have a new instance on develop ready for validation, right? So that's pretty basic, and it worked very well because obviously you had the standard quality controls in there. So when in Git you could do the code reviews and stuff like that. So there was already quite a lot there before we arrived. And you really need such a thing before you can continue working. Otherwise, why automate security if development hasn't been automated yet? So, what did we have to add up to that? Well, first of all, we started adding the OWASP dependency checker. That's what we had to add, and a few other dependency checkers for third-party vulnerabilities. A bunch of license checkers to verify that we weren't violating some of the internal policies of the company, because they had a policy on what licenses they do accept for third-party resources and what they didn't. And normally people had to manually grab that. And that was a cumbersome thing. You don't want that. And then we started to do something with Docker security in general. Obviously, there's a lot of tools you can use. We just had to use one back then to start getting at least some minimal insights on what might be possibly wrong. And we use Claire for that. Who of you knows Claire? All right, for those who doesn't know, Claire is basically an inspector tool that is part of a larger commercial tool suite, but this one has been, the tool itself has been open sourced. It will use a set of vulnerability databases as resources to then verify the layers within a Docker container to see if some of the known vulnerabilities could be linked to that, and then report on that, which makes it relatively easy to just, when you create your container, then offer it to Claire, and could just dissect the layers and then tell you what possibly might be wrong there. Of course, this is a theoretical thing, because after all, those vulnerabilities might be there in one of the layers, but the layer on top of that might mitigate that. So you will get some problems there, but at least you get some basic insight on what might be possibly wrong with the container. And at the point that we started, the customer had no clue about it. Everybody just created their container, start deploying. So this would give a basic insight. Next, of course, well, you know them, right? Zap and Burp. Some other tooling which is less important. And we wanted to do also static source code analysis. But who of you is familiar with Scala? Not too many, actually. So Scala is a high scalable language, which is actually by itself a scalable language because you can provide AppSec syntax trees on top of that, bunch of cool macros, and then basically create kind of your own language. That's not something a SaaS tool is going to understand right now, because the hard part with this is that there are some tools like Checkmarks and Fortify that support the basics of it. But the moment a developer goes wild, you'll see that it's going to miss out a lot. So we figured let's not buy one something and continue. The other hard player in the field was this little buddy. Who knows that icon? Recognizes it? No. Swift? Yeah, exactly, Swift. So we have a bunch of mobile developers in that team that always like to use the latest and great stuff, basically. Well, that's not where your SaaS tooling is optimized for. So yeah, here you go. You have to go all runtime in there. Or at least that's what we had to do. Of course, you could say, as the bad police, thou shalt not use latest and greatest, but be a bit, you know, less progressive. But that wasn't the company culture, so we couldn't do that just like that. All right. So, well, what was the solution? Basically, we got there kind of. First of all, to get feedback as soon as possible, you have to add dependency and license checkers on top of the quality tooling you already have. With tooling, it can be configured in a way that really makes sense. So, a Maven plugin for your Maven build pipeline, a JavaScript plugin for your build pipeline. Make sure it's really simple and easy for developers to understand. And give that feedback fast, because this is very easy. This is a quick win they can always check out. And then if you take a look at the earlier container, basically what you add over here is Claire. That's not really that important. But the hard part is, of course, now that you have all this, is now you have to basically tell Zap and Burp, before you can use it, how the applications are working. Well, there was a beautiful presentation before me that just showed that you no longer have to do that way. But at the end of 2016, we kind of had to. Sorry about that. So, yeah, we basically had to teach the API using the end-to-end integration tests, and then test coverage became a thing, because all of a sudden we from security had a really big opinion about the end-to-end integration test, because if you wouldn't test that, we wouldn't know. So off you go, start testing. And actually the POs love this. That's a good thing. And then after that, you could just kick off a quick scan with using the REST APIs. At least for Zap, we were able to do that. For Burp, we just graded out a bit, and I'll get back to that later, why. That's part of the failure, basically. And then you would have a artifact running on dev that will be scheduled for a longer scan afterwards. So then Zap could do a full scan, and we could see what else is in there. So this is basically the setup. As I already discussed, in up to Java and Git, everything was already fairly annotated, so you could track why some code is in there. So all we had to do was make sure that the moment that you would kick off Zap and you would then report to ThreadFix, so yeah, we chose ThreadFix back then, at least the open source version, compile it ourselves, put it in a container, start running. And then we could just verify because of the stuff that would be kicked out, and you could augment the report basically to make sure that in ThreadFix you could still see to which Git branches belonged. And by that, it wasn't too hard to track back what causes it in the first place. Of course, this is a very disciplined approach, because this means that the developer should never ever do something else and always annotate this Git commit with the right Jira ticket. So luckily you can do this far better right now, but then again, this is how it was back then. The harder part, of course, was that Zap would just give some feedback, which will be stored by Jenkins in an S3 bucket, which is unfiltered. So if it found something which was a false positive, the developer would immediately already be warned by that. So we basically had to give a pass-through there. That was a bit of a sad thing. The other thing, of course, is that once you did get the results, you have to feed that back to Jenkins again, filtered. So there is some delay there. Luckily, the moment you set up your basic false positive filtering, because the first long scans will provide you a lot of data on which is either right or wrong, so you can start suppressing the false positives from there onward, and then stuff actually gets better. But the first one is the expensive one. And then after that, we will use ThreadFix to just submit stories to Jira. Obviously, after talking to the developers. One thing that a developer, at least I, when I'm developing, really dislike, is if some other guy starts just adding stories to my backlog, because, you know, I as a developer need to be in control of that, and I don't care what security thinks. I need to deliver value, let me do that. But if the security guy sits next to me at the moment that, you know, some standard moment in a week, unless it's a high vulnerability, and starts talking to me like, hey, I'm sorry, but look at the computer. This is what we found, and we have to do something about that. Can we please, can I provide you a story, and then you can, and then we can refine it together later on and just make it work. And it worked pretty well. So yeah, talk first, integrate later. So although this is all automated now, you really